Alright guys, today we're going to start talking about monomials and polynomials. So, first of all, we need to talk about what a monomial is. And a monomial is an expression, so there's no equal sign, that can be written as a real number, a variable number, or a product of a real number and one or more variables with non-negative powers. Now this is a really intense definition, so I'm going to narrow it down to 3 rules. There are 3 rules to be a monomial. Rule number 1, there's no addition or subtraction allowed, meaning we can't have something like this. That has an addition sign, which means that I have 2 terms. So basically we're looking for one term to be a monomial. And then rule number 2 is that we can't have any variables in the denominator. So I don't want to see anything like this, like 2 over x or 3 over y squared. That's not a monomial. And then finally, we can't have any negative exponents, no x to the negative second or y to the negative fourth. So the 3 rules is no addition or subtraction, no variables in the denominator, and no negative exponents. So if an expression follows these 3 rules, then it would be a monomial. Now some examples. 3x is a monomial. Notice there's no addition or subtraction, there's no variable in the denominator, and there's no negative exponents. 16t squared is also a monomial. X squared y to the fourth. Now I know that this can kind of confuse some people because we have 2 variables in one term, but again there's no addition or subtraction sign, so it's definitely a monomial. And then 5 is a monomial. A real number is definitely a monomial. Now, on 1 through 6, we're going to go through and determine whether each expression is a monomial. We're going to write yes or no, and we have to explain. So we're just going to see if it follows the 3 rules. So on number 11, there's no addition or subtraction sign, I don't have a variable in the denominator, and I don't have a negative exponent. That means this is definitely a monomial. Now, if I want to talk about why and explain, if I go back up to the actual definition, a monomial can be written as a real number. And 11 is definitely a real number. So I'm going to say yeah, because real numbers are monomials. And if you need to pause the video and write that down, you can. On number 2, I have a minus b. Now right off the bat, I have a subtraction sign, which means this can't be a monomial. So I'm going to say no, because subtraction separates the terms. Or if you want, you could say something like no, monomials can't have subtraction. On number 3, I have p squared over r squared. Now, right off the bat, I hope you notice that we have a variable in the denominator, and that can't happen. So no, you can't have variables in the denominator in a monomial. On number 4, I don't have addition or subtraction. I don't have a variable in the denominator, meaning like this doesn't have a fraction bar over it with a number. And I don't have a negative exponent. So that means this is a monomial. Now to explain why, I can go back and look at the definition again. Now the definition said it can be written as a real number, a variable, or a product of a real number and one or more variables. Now this is just a variable and it has a positive exponent. So I'm going to say yeah, variables with positive exponents are monomials. On number 5, I don't see any addition or subtraction signs, there's no variables in a denominator, and I don't have any negative exponents. Now, I have 2 variables in this term, but they're combined using multiplication. So that means, again, this is a monomial because it's the product of variables with positive exponents. On number 6, right away, there's an addition sign separating these 2 terms. So this is not a monomial because addition separates terms. Okay, now the next thing I want to talk to you about is the degree. So monomials have something called a degree, and the degree is the sum of the exponents of the variables in the expression. So in the following examples, let's look at the degrees of the monomials. So on this first one, on 3x, I want to look at what the exponent is. Well, if you'll notice, 3x has no exponent, which really means that it's an exponent of 1. Now that's the only variable in here, so that just means that my monomial has a degree of 1. 16t squared, that has an exponent of 2, which means that my monomial has a degree of 2. Now, on x squared y to the fourth, this has two different variables with two different exponents. So to find the degree of the entire term, I need to take both of these exponents and add them together, and I'm going to get 6, which means that my monomial has a degree of 6. And finally, 5 is a constant. Well, a constant doesn't have a variable, which means that it has a degree of 0. So, on 7 through 12 it says, an expression is given. On part A, we want to tell if the expression is a monomial. On part B, if it is a monomial, we need to give its degree. On number 7, 5t to the fourth. So first we need to tell if it is a monomial. Well, there's no addition or subtraction. I don't have a variable in the denominator, and my exponent's currently positive. So that means yes, this is a monomial. Now I just have to give its degree. I only have one variable, and its exponent is 4, so that means the degree is 4. On number 8, again, there's no addition or subtraction. I don't have a variable in the denominator, and I have a positive exponent. So again, this is a monomial. Now since I only have one variable, the exponent, which is 2, is my degree. On number 9, there's no addition or subtraction. We have nothing in the denominator, but I have an exponent that's negative right here. So since that's a negative exponent, this is not a monomial. That means it can't have a degree, and we don't do anything else on that problem. On number 10, I have 1/2 b times h. Now, we don't have any addition or subtraction. The variables are not in the denominator, i.e. I have a fraction here, but what's important is that it doesn't say 1/2 times bh. That would be a variable in the denominator. This bh is being multiplied by the fraction in a way that means that if I were to simplify that and turn these all into fractions and multiply it, they would end up in the numerator. So that's okay. And I don't have any negative exponents, which means that this is a monomial. Now, to determine its degree, I need to look at the variables. Here I have two variables, so I need to add their exponents. So I have a b to the first and an h to the first. When I add those together, I get a degree of 2. What I'd like you to do next is pause the video and do number 11 on your own. Hopefully, on 11 you found out that this is a monomial because there's no addition or subtraction, no variables in the denominator, and no negative exponents. And its degree would be adding all three of these together to get a degree of 12. Again, pause the video and do number 12 on your own. Hopefully you see that this is not a monomial. This has an addition sign which separates terms. Now the next thing I want to talk to you about is a polynomial. And a polynomial is an expression that is either a monomial or a sum of monomials. So, some polynomials have special names. For example, monomials only have one term because the prefix mono means one. Binomial means that you have a polynomial with two terms because the prefix bi means two, like a bicycle. And trinomial is a polynomial with three terms because the prefix tri means three, kind of like a tricycle. Now, the degree of a polynomial will be the highest degree of any of its terms after the polynomial has been simplified. So for example, this guy right here is a polynomial, 7x squared minus 3x plus 5. That is a sum of monomials, so 7x squared minus 3x plus 5. All three of those are monomials. There are three terms, so that would make this a trinomial. Now, if I were to look at each term individually, 7x squared has a degree of 2, 3x has a degree of 1, and 5 has a degree of 0. But the entire polynomial has a degree of 2, since that is the highest term with the highest degree. So let's give this a shot. On number 13, it wants to know which of these multiple options are binomials. So which ones have 2 terms? Well, if I go through, A has 2 terms, so that's a binomial. B has 3 terms. C has 3 terms. D has 3 terms. And E only has 1 term. So my binomials are just part A. Now in number 14, it wants to know which are trinomials, meaning which of them have 3 terms. Well, we know A doesn't work because we just said it's a binomial, but B has 3 terms, C has 3 terms, and D has 3 terms. E has 1 term, so that is still a monomial. On number 15, it wants to know which have a degree of 2. Now to know that, I have to figure out the degree of each one of my terms so I can find out which is the highest. So if I were to look at part A, x squared has a degree of 2 and 5 has a degree of 0. Now the biggest of those degrees is 2. That means part A has a degree of 2. Now part B, x squared has a degree of 2, 5x has a degree of 1, and 6 has a degree of 0. Now again, I don't add these 3 together, I just find the biggest one. And 2 is the biggest one, so part B also has a degree of 2. Part C, x squared has a degree of 2, 5xy has 2 variables, so I need to add their exponents together. And 1 plus 1 gives me a degree of 2 for this term, and y squared also has a degree of 2. Now since these are all the same, I don't have to worry about which one's bigger. My degree is just 2. So part C also has a degree of 2. On part D, x cubed has a degree of 3, 5x squared has a degree of 2, and 6x has a degree of 1. So the biggest of these degrees is 3, so the degree of part D is 3. Finally, on part E, we have a monomial, so I need to add all 3 of those exponents together. So x to the first, y to the third, w to the fourth. 1 plus 3 plus 4 gives me a degree of 8, so the degree of this monomial is 8. So the degree 2 is A, B, and C. On number 16, it wants to know which have a degree of 3. Well, we've already done this work. The degree of 3 is letter D. Now finally, I want to talk about how to put polynomials into standard form. Standard form is kind of like a nice organized way to write your polynomial. For example, when you think of slope-intercept form, that's like a nice way to organize a linear equation, y equals mx plus b. If you'll remember back in chapter 2, I had to do a lot of rearranging to get things into this order so we could graph them in chapter 3. Now, when you're dealing with a polynomial with multiple terms with multiple exponents, to make sure it's in standard form, you need to arrange its terms in order from highest degree to lowest degree. So on 17 through 20, it wants us to write each polynomial in standard form, then identify the leading coefficient. So on number 17, I have 3x plus 1 plus 2x squared. Now I'm not going to do any solving. I'm just going to rearrange this since there's no equal sign. So the first thing I want to do is I want to identify the degree of each term. 3x has a degree of 1, 1 has a degree of 0, and 2x squared has a degree of 2. So to put it in standard form, I need to put it in order from highest degree to lowest degree. So the highest degree here is 2, so that term 2x squared goes first. The next highest degree is 1, so the term 3x goes second. And the least highest degree is 0, so this constant needs to go last. So 2x squared plus 3x plus 1 is in standard form. Now I need to identify the leading coefficient, and I can only do that when it's in standard form. When it's in standard form, the leading coefficient is going to be the coefficient of your first term. Now remember, coefficient means the number in front of the variable. So 2x squared plus 3x plus 1 is in standard form. My first term is 2x squared, and my coefficient is 2. So that means my leading coefficient is 2. On number 18, I'm going to start again by identifying my degrees. 5x has a degree of 1, negative 6 has a degree of 0, and 3x squared has a degree of 2. So I need to rearrange them so the degrees go in numerical order, highest to lowest. So, not numerical order, just in order from highest to lowest. So the degree of 2 goes first, so 3x squared is my first term, followed by 5x, ending with minus 6. Now that it is in standard form, my leading coefficient is the number in front of my first term, which is 3. On number 18, I have 9x squared plus 2 plus x cubed plus x. Let's look at my degrees. So 9x squared has a degree of 2, 2 has a degree of 0, x to the third has a degree of 3, and x has a degree of, what is going on? Good, let me try this again. 3, and x has a degree of 1. So in order from highest to lowest, degree 3 goes first, so x to the third. Then degree 2 goes second, so plus 9x squared, degree 1 plus x, degree 0 plus 2. Now the leading coefficient is the coefficient in front of my first term. Well, here's my first term, and as you can see, it doesn't look like there's a coefficient there. But remember, when there's not a number there, it really means that it's a 1. Alright, what I'd like you to do is pause the video and do number 20 on your own. Alright, hopefully you went through and you saw that this has a degree of 0, 3, 2, and 1. And I can rearrange it as 3x to the third power minus x squared plus 4x minus 3. And my leading coefficient is 3.